Hi guys, in this video we're going to continue talking about those measures of central tendency, but really we're going to go a little bit further and start looking at how our data is distributed. So first you'll see we've got this data distribution. So what is data distribution? So when we're looking at data distribution, it's just the way that the values are clustered or centered. So it's the way the values are clustered. So I want you to think about a cluster of things, meaning just where more of the data falls. So we've got really three different types of distribution, and it's kind of backwards to me, and so it's just kind of one of these things we just have to remember. So this first example, this is where our data is positively skewed. See how it seems backwards? To me, since more of my data is kind of on that negative side, it would seem to me to be negatively skewed, but we're looking at where the tail is. That's kind of where I want you to look at, is where's the tail? And since here the tail would be towards the positive side, then this is our positively skewed data, which would make this second piece our negative. Whoa. Negatively skewed. Okay, since the tail is going more towards that negative side, that's going to be our negatively skewed. This third and final one is one we're going to really talk about. This is a normal distribution. And that's really where we're going to look at and spend a lot of times, which is pretty cool. Once we dig into the data, it makes it pretty cool to look at. So in normal distribution, it is a symmetrical bell-shaped curve. That's kind of upside down. So we'll start low, kind of go up, and then come back down. That's what our normal distribution looks like. So we really are defined by the mean and our standard deviation. So in that last video, I showed you how to find the standard deviation. We're really going to be using that. Most of the time, we don't even have to find that. We're told that information when we're dealing with our data. We're really going to look at what that means and what it looks like now. Okay, so the area underneath the curve. So remember that we're looking underneath the curve here, so that's this entire area that I could color in. So that area represents probability. Okay, and the total area, so if I was to add everything all together, my probability would be 1. So remember when we talked probability, probability is anything between 0 and 1. 0 meaning not ever going to happen, 1 meaning I guarantee it to happen. So if we look at the curve, I can guarantee my data will fall underneath that curve. So that's why our probability would be 1 there. So now let's look at our normal distribution curve. And this is something you are absolutely definitely going to need to write down and refer back to. So here in my curve, I see that my mean is right in the very center. It's the highest part of my data. What's pretty cool is from here I'm using standard deviation. So remember, a standard deviation was kind of how far away the data is from the mean. Okay, so when we're looking at this, I know that 68.2% of my data falls within one standard deviation. So this purple would encompass 68.2% of all of the data in this set. Well, so then if I look at my second standard deviation, I notice that 95.4% falls within that category. So again, if my data is in here, right, to 2 standard deviations on both sides, I would have 95.4% of my data. And so now if I'm looking at that 3 standard deviations, it's going to be 99.8% of my data will fall within this category right here. Okay. So the other thing I want you to look at and notice is, yes, my mean is in the middle. What that also tells me that is above my mean, I've got 50% of my data above, and I've got 50% of my data below. Okay, I'm going to go ahead and erase this information in here because there's some other ways that we can break it down. So if you want to use arrows or if you want to redraw your curve, that would be sweet too. So because I know that there's 68.2% of all of the data falling between my -1 standard deviation and my positive standard deviation, I know that in this little rectangle, or in this little spot right here, I have 34.1% of my data will fall within there. Same thing down here. Since we did say above that this is symmetrical around the mean, right? Whatever I write here on this right side can also be said for the left side. Based on what we know about these data values, I also know that 13.6% of my data will fall in this little category right here. And then over here, I know that 2.2% of my data falls right in here. And then I know, right, that there's some data that's way outside, but it's going to be a very little 0.1% of my data falls outside those 3 standard deviations. So I want you to think of just taking this distribution curve and folding it in half so these numbers can go on this side as well. So when we're doing this and using this standard deviation, we first always want to draw our distribution curve. Okay, and so this turned out a little funky. Your paper should look just fine. But here's our general distribution curve. So now let's fill in what we know based on our information, and we can go from there. So for this first question I have, the weights of 50 football players are normally distributed, which tells me in the sentence I know that I'm dealing with this curve, with a mean of 178 pounds and a standard deviation of 8 pounds. Well, what that tells me is first I'm going to draw my picture so then I can use that picture to help me answer the questions. Let me see if I can make a little bit more space. I can to draw this. Perfect. So I see that my mean is 178, so I know that goes right in the middle. Okay, and I know that one standard deviation is 8 pounds. So if I add 8 pounds to that, I end up at 186. If I add 8 pounds again, I'm at 194. And if I add 8 pounds again, I'm at 202. Just like I added, I'm also going to subtract. So I'd go down to 170, then it would be 162, and then finally here it would be 154. So using this curve and the information above in our just general curve, these numbers right here, we're now able to answer the questions. So this asks me what percent of the players weigh between 178 and 194 pounds. So let's look at that. So I'm told between 178 and 194. So that tells me I need these 2 chunks, the first standard deviation chunk and the second standard deviation chunk. So then I can go back up here and look. Well, my first one was 34.1%, and I have that 13.6%. So when I add those 2 together, I end up with 47.7%. So just using this values above, I don't have to do a whole lot of the math. Okay? So then looking at part B, what is the probability that a player weighs at most 170 pounds? So when I'm dealing with it at most, that tells me I'm looking at 170 and I'm looking this direction. Because it could be anywhere less than that. So we can look at what all of these add together, or I can look at what these add and then subtract them from 1. So just looking at my curve above, I know I'm going to be adding my 13.6 and my 2.2 and my 0.1 together because those are the same down here on this side, remember, since it's symmetrical, and I end up with 15.9%. That's a probability that one of my players would fall into this category of weighing less than, at most, right, 170. So now let's look at part C. What's the probability that a player weighs less than 162 or greater than 194? So here you can hopefully see why we always draw this out first so I can see exactly what I'm looking at. So I need less than 162 or greater than 194. Okay, so nothing in that middle chunk, just these. So I see that I'm 2 standard deviations away and going this direction, and 2 standard deviations on the positive side and going that way. So I can go back up and look at my distribution curve. So I see I would be in this little chunk right here and this little chunk right here. So when I go ahead and I add those things together, I would have 2.3% down on the bottom part being less than that 162, and I would have 2.3% being on that greater than 194 part. So I would end up with 4.6%. Okay. So now we can take this information too and figure out exactly not just the probability, but how many players fall into a certain category. So that's what we're going to do with this last problem and using this data set. So how many players weigh between 170 and 186? So I see I'm looking right there. I'm looking at one standard deviation from the mean on both sides. Well, I know that that whole chunk between those two values is 68.2%. I knew that I also started with 50 players. So if I can figure out what 68.2% of 50 players is, and that's where I'm going to go ahead and multiply, would give me 34 players. So all I have to do there is take the percentages that I know and the player numbers that I know and then multiply those to kind of get how many players fall into that category. So now there's a couple more examples for you guys to work on. So the first step is always going to be dealing with your distribution curve. Draw it out, say, okay, so here's my mean, here's what each value of my standard deviations is. So then you can use that in in conjunction with, together with your just normal distribution curve and use that information to kind of help you figure these out. So I will also go ahead and post all the answers here so you can double check that you're doing things right and that you're looking at the right stuff. So now that we've gone through both of these videos and looked at all of our data and our just how we can measure data and look at this data, so now it's time for you to go work on the homework number 6. And let me know whenever you get stuck. Thanks, guys.